Discuss about the volume of distribution. So in the volume of distribution, what they are saying in the definition, it is defined as the volume in which the amount of drug would need to be uniformly distributed to produce the observed blood concentration. So in these cases, what will happen? I will show you one the experiment like this volume of distribution. This is it is the one of the it is called as the one of the compartment, like a broad compartment or a plasma compartment. So in these cases you have to take the drug by injects by oral route or a parenteral. Then what will happen? Your drug will go to and then it will be distributed. After some times what will happen here? You will reach the drug will be digital. If you see like this, this is your blood compartment, and from the blood compartment it will go to your various organ. So in these cases the means the apparent volume, then drug dissolve and reaches the equilibrium. So after taking the drugs or injected by the oral route or parenteral, after some time the equilibrium will be reached. Then when your equilibrium will be reached, you have to take the go for the concentration to measure the concentration, blood concentration. So if you see after some times what will happen? They will be uniformly distributed. Then after this it will be go to the rest of the body. Then second one, what they say, it is also called as the apparent volume of distribution. It is also called as the apparent volume of distribution, means the quantify the distribution of the drug between the plasma and rest of the body. What will happen after uniformly distributed in the blood compartment or the plasma compartment? Then what will happen? It will go to another compartment, means it is called as the rest of the body. So that's why the quantify the distribution of the drug between the plasma and rest of the body after oral or a parenteral dosing. So I given, for example, I given this is the one of the compartment. I put the drugs. Then after some time, if you see, it is uniformly distribution will become. Then after this, it will be go to the rest of the body. That's why the blood will be there. This is your one compartment, like a blood compartment, and then it will go to your various organ. So in this case, when it will go to your various organ, so what will happen? It will be also called as the apparent volume, means it is because the all parts of the body equilibrated with the drug, but this is the important points, don't have the equal concentration. They don't have the equal concentration. So because the different tissues will receive the different amount of the drugs and different rate, that's why it is called as the don't have the equal concentration. So I given this like this. This is one compartment. So you are giving the for example, you are giving the dose. It is called as the 100 mg, and the concentration you reach, you got the concentration. It is nothing but 10 mg per liter. We got the concentration is 10 mg per liter. So I have given 100 mg of the drug, and after if you see the apparent volume, then drug will be dissolved uniformly, then it will be reaches the equilibrium. So then after this, you will, after reaching the equilibrium, you have to take the samples and go for the concentration to measure the concentration. You find out the 10 mg per liter you got the concentration. So it is also, then if you go for the calculation, for example, the X is directly proportional to the C. So X means the amount of drug in the body, and C means the concentration of the drug. So then X is equal to some constant you have to put. It is called as the Vd into C. Then Vd is equal to X by C, means amount of drug in the body divided by plasma drug concentration. X is nothing but amount of drug in the body divided by plasma drug concentration. If you see the general equation, the concentration is equal to weight or mass by the volume. We generally call it the concentration is equal to weight or mass by the volume, and volume is equal to, you can write down weight or mass by concentration. So if you see like this, so what is your mass? You have taken 100 mg, you have given the 100 mg of the drug, and what is your concentration? You got 10 mg per liter. Then what is your body Vd will become? Now weight by concentration or mass by concentration. So 100 mg by 10 mg per liter. Then mg will be cancelled, and 10 will be here, and mg will cancel. Then how much will be there? Now Vd is equal to 10 liters. So now like this you have to calculate the volume of distribution. Similarly, if you go for suppose 500 mg and 5 mg concentration per liter will be there, then it will be your give is the 100 liters. So like this is about the definition of your volume of distribution. It is also called as apparent volume of distribution, means your drug will be distributed between your plasma and rest of the body. And also it is called as the apparent volume, means all parts of the body equilibrated with the drug but don't have the equal concentration. Then come to your application. Application means what purpose you can be used. It can be used to calculate the loading dose, also can be calculated by the volume of distribution. Clearance also you can be calculated, and total amount of drug which are present in the body also you can be calculated. This is about your application. Then you have to go for this classification. How we are classified the volume of distribution? One is the VC. VC means volume of distribution in the central compartment. And another one is you can be classified as the VD area, volume of distribution in a area. And VDSS means volume of distribution in the steady state concentration. So next we will discuss about the factor affecting volume of distribution, along with what are the marker you can be used to calculate the volume of distribution, and I will give you some example about the volume of distributions. And now the factor affecting volume of distribution. Now we will discuss the factor affecting volume of distribution. First is the ECF, extracellular fluid. In the children, the total body water will be large, and volume of distribution also it will be large. So what is about the TBW, total body water? So total body water will be 42 liters. So you have to remember the total body water will be 42 liter in a 70 kg person. So here is the divided into three parts. One is the plasma, 4 liters will be there. The interstitial fluid, it will be 10 liters. And intracellular fluid, it will be 28 liters. If you see the plasma and the interstitial fluid, it will be called as the extracellular fluid. So extracellular fluid will be 14 liters. 10 liter plus 4 liter, it will be 40 liter. 14 liters, and intracellular fluid will be 28 liters. So if you go for the total body water, it is coming under 42 liters. So then next is the tissue binding. So tissue binding, if you tissue perfusion, if your more tissue perfusion will be there, the volume of distribution also it will be decreases. The next one is the plasma protein binding. In the plasma protein binding, if your drug is more plasma protein binding, your volume of distribution also it will be decreases. So the next one is the water soluble drug. Water soluble drug, if your water soluble drug, always your volume of distribution means the hydrophilic drug, if you are using, the volume of distribution will be decreases. For example, gentamicin, the volume of distribution is only 110 ml per 70 kg persons. Then next one is the lipid soluble drug. Lipid soluble drug, if you are using, or a lipophilic drug you are using, the volume of distribution will be high. Means for example, your thiopental, one of the drug they are using, the volume of distribution is 2.3 liter or 2300 ml per kg. Similarly, acidic drugs. If you are using the acidic drugs, then your volume of distribution is decreasing. So for example, valproic acid, the volume of distribution is only 220 ml per kg. Then come to your basic drugs. The basic drug, if you are using, their volume of distribution will be increases. So for example, amphetamine, your volume of distribution is 4 liter per kg. Similarly, if you go for the tissue binding, if you are more tissue binding, your volume of distribution also it will be increasing. For example, chloroquine. The chloroquine, your volume of distribution is 15,000 liter per kg. Similarly, if you are using the low molecular weight of the drug, your volume of distribution also it is increasing, because the low molecular weight it indicates the lipid soluble drug. So that's why in the lipid soluble your volume of distribution is also increases. Similarly, low molecular weight your volume of distribution will be increases. These are the factors affecting volume of distribution. How your volume of distribution will be increasing or decreasing, in which case. So these are the parameters I have studied. Then come to this. What are the marker you can be used to calculate the volume of distribution? This is called as the specific markers. So if you go for this, how to calculate the volume of distribution. So this is the fluid compartment, this is your marker used, and apartment volumes, how much you have to use. So these are the three columns I given. One is fluid compartment, it is the plasma. The marker you can be used like an even blue, and it is 4 liters approximately you have to use. Then come to your ECF, extracellular fluid. The marker you are using the inulin and the mannitol, and the 14 liters will be there. Then come to your total body water, D2O2 and antipyrine, the marker you can be used. and 42 liters will be there here apparent volume. So I am giving some example about your volume of distribution. So in the heparin, it will coming the 5 liter per 70 kg person, aspirin 11 liter, and digoxin is 420 liters. So these are about your volume of distributions. And now I already discussed about the application, classification, definition, and then come to a factor affecting volume of distribution, with what are the marker it can be used to calculate, and what is the examples of your volume of distribution. And also very important parameter important is the how much the total body water, and the total body water also I have discussed. So these are about your the volume of distributions.